Good afternoon or good morning. My name is Bradley Johnson. I work for Basefield Americas as a lead solution architect, and we're here to talk about digitalization and how to really, what it is and how to achieve it in your organization without causing too much problems, I guess you could say. So this is the weirdest presentation for a conference, obviously, I've ever given. I really only signed up for it just to document how long my hair actually is, just to keep it for my son as he grows up, that I did at one point look like this. I don't have a fancy Zoom background. This is my actual office here. You can see it's fully equipped with my own playpen behind the scenes. After a few hours of meetings or a few hours of coding, sometimes I just need to cut loose and play with my blocks and my teddy bear. So excuse the mess, but you know, it is what it is. So let's get going on this presentation. Hopefully we keep it light, entertaining. God knows we all need it. Cool, quick overview. What is digitalization? What is it really without all these buzzwords? That's what I want to get down to. What are some common struggles that organizations have when trying to achieve digitalization, specifically within the renewable industry? Based on our experience, there's a few common pitfalls that we see that are kind of can be broken quite easily with kind of behavioral habits as well as technology. One of those pitfalls that can be kind of easily overachieved can be overachieved by establishing clear roles and responsibilities in your organization, and really who does what. And specifically, we're going to talk about who should do what and what should they do from a digital standpoint. How can you truly efficiently run an operations organization in renewables and wind amongst all these different groups so they can collaborate together, and what should they do on a daily basis with their tools? So that's what we'll get into at the second half of the presentation. So what's digitalization? From a generic standpoint, to me, it's the use of numbers, data, and algorithms to make informed decisions as opposed to uninformed decisions, and to improve your organizational and asset performance, right? That's a generic definition that I would say is valid. From a wind or renewable standpoint, it's really, in my opinion, tell me what's broke, why it's broke, and how much money I'm losing. Digitalization is the key to really solving that problem. I think as an industry, and not just our industry though, there's a lot of confusion and hype around this concept. There's all these buzzwords surrounding that you've all probably heard, you know, IT, OT, IoT, Edge, ML, AI, and it's just, for me at least, my head scratching and just leaves me sitting there. In reality, a lot of these buzzwords are created by smart people to create hype and to sell you products that you don't need and you won't use. And it's my job to sell those products. So I'm coming as you from an engineering standpoint. It can get quite confusing, and it was pretty interesting. I was reading an online article recently that had this chart here on the right. This is a hype cycle for emerging technologies. So all these acronyms, all these digital solutions are placed kind of on this different curve here. And really, as they become popular, they reach a peak of hype where everyone's talking about them, everyone's trying, et cetera, et cetera. And then a lot of people try them, they fail. And so really some of those solutions are abandoned, and we get into this trough of disillusionment that it's called, where there's been a lot of abandonment of a potentially useful solution because of early failures. And then finally, in reality, that solution will reach some level of plateau of productivity, because when we talk about AI, we talk about machine learning, these are important concepts that can produce value. Unfortunately, I think they're very much overhyped. And I think if we look at where we are in the renewable space and the wind space, I think we're kind of getting into this trough now where we've been talking about all these things, these digital concepts, for the past 2 to 5 years, and there's been some organizations that have really gotten it, and some that have not. And I think we're slowly getting into this trough. And so I think it's important to look at, you know, how can we avoid this trough from dipping too much into the trough, too below. So I wanted to focus on really how to try and avoid that, and how to avoid that in your organization. So how do we avoid that? How do we achieve digitalization? Really, it's about, to me, overcoming two major pitfalls. The first is more cultural and sometimes even political. Organizations suffer from a lack of transparency, politics, and really that happens because there's not a good sense of roles and responsibilities within the groups. And we'll go over kind of these groups and how they can be structured in the next few slides, but it's not so much of a technical issue, it's more of an organizational issue. The second one is a technical pitfall because either you have too much software and too much stuff that you're trying to do, or you have too little and you're trying to do everything on your own. And in reality, in my opinion, number two results from number one. When you have all these different groups and they're each trying to do their own thing and they're not talking, sometimes it can cause organizations to invest in too much software or too little, and everyone tries to do their own kind of analysis and algorithms, and then at the end of a year or two, it's just all a mess. So really these two pitfalls can be solved simultaneously through really organized decision-making on what software you should choose. And really the most important part is organized rollouts and training of that software. If I look at successful Basefield rollouts with customers, it's the customers that really have managed the rollout and training within the platform in a very organized manner. So it's incredibly important to overcome that number one and number two. So let's talk about what an organization might typically look like. Hopefully, after you see this, a lot of you are shaking your head. If you look at 500 megawatt, gigawatt plus organizations, loosely there's four or five generic stakeholders in terms of digitalizations and digital platforms. At the bottom, of course, there's the operators. They're the people that are the most knowledgeable about the assets. I guess in the blue, this is what those people would think about themselves, and in the red is what the other groups might think of them. So we have the operators, which are the most knowledgeable and can fix the actual issues. You have the engineers that are really good at data, and they can come up with fixes as well. Unfortunately, they think they're smarter than they are, and unfortunately, the operators generally don't like to work with the engineers or the asset managers as much because they can usually solve the problems themselves. Then you have the asset managers, which can see and sit on top of both of those and really direct priorities and direct financials and direct budgets. A lot of the times, they're not the most overly technical people, though, so they really need to be educated by the lower two levels. And the bosses sit above all three of these groups, and really, the boss is the executive management. At the end of the day, they want some pretty pictures, right? Then kind of off on the side, you got IT, right? And it's never their fault. Something goes wrong, not their fault. But that's the way that you kind of see. And unfortunately, this kind of vertical organization can cause a lot of problems, because what happens is because of some of these cultural issues, or if you don't have a real transparent data platform that allows like transparent sharing between organizations about how well your power plants are doing, how much power they're producing, how much power they're losing, you come across a lot of different problems, right? You have ideas and methodologies which are not shared across these brick walls. Ideas and methodologies aren't shared amongst the groups. Each group does their own thing. And then at the top of the ladder there, the executive management, as a result, they don't get the information they need to make decisions. So decisions then come top down as opposed to bottom up. The asset managers, the engineers, and the operators aren't happy about that because they feel their ideas aren't being taken into account. And the bosses really become the bosses as opposed to the audience. In reality, in a good digital organization, the asset managers and the executive managers should be the audience of data. They shouldn't be the strict decision makers to pass down decisions down to the engineers and the operators. Finally, my favorite kind of consequence of not having a good digital organization set up is that everyone, of course, blames IT. And you got the guy in the corner here, of course, sad because everyone's yelling at him because something's wrong with the data or something's wrong with the report or something, So for IT, it's not always their fault. Mostly is, but not always. So how do we take that organization and we transform it to something like this, a more horizontal organization where engineering, asset management, and operators are working really hand in hand? We want information to flow horizontally first and then vertically. And that really, those yellow lines, digitalization, IT, and software should be the conduit which drives that, so that everybody's looking at the same information, everybody's looking at the same data, everyone's looking at the same alarms, everyone's looking at the same power curves, everyone's looking at the same events and reports. Then it's easy to get a consensus of performance on your fleet so that you can share that with executive managers and they can make truly informed decisions about further investments, divestments, new acquisitions, new build outs, et cetera, et cetera. Very important to get the organization more like this than more that traditional bot or vertical organization. To get it like this, really critical to define roles and responsibilities. Who does what? And I'm not going to spend too much time on this RACI chart, but this is kind of some common uses and what of those groups, who of those groups should be responsible to actually doing the work, who should be consulted for help, who should be informed, and who should ultimately, at the end of the day, be accountable, which is largely the executive management, right? I'll leave this in the slides. Another big use case for operators is just to help the asset managers and the engineers by reviewing daily performance reports and reviewing daily event logs. So in order to get accurate fleet-wide availability numbers, for example, you really need to have some level of operations involved to correct and edit potential discrepancies in events so that, you know, if you have a BOP outage from 12:25 to 2:13, that time is correctly allocated towards a BOP outage so that the lost energy can count against BOP. So that at the end of the day, the asset manager and the executive management knows how much money they lost because of a splice issue or something. So they can make the right decision whether or not to focus on that in the future or to do a better design in the future. So we'll get into now a few live demonstrations of a few of these use cases now for operations before we move on. So I'm going to hop over to our little Basefield portal to first talk about the centralized control and operating site level stuff. So this is an asset operations application. I'm just going to zoom in. And you can see this is giving real-time data on all various types of assets in a fleet: wind, solar, hydro, battery, doesn't matter. I'll just zoom into a specific site, a certain wind site for now, and hit apply, and I'll get all my assets. Now, obviously, there's all the OEM SCADAs, but sometimes in large organizations, you need an overlay to try and control multiple sites at once, or at least have one system that can touch all systems, right? That can allow you to do single asset control, start, stops, and resets, multiple asset control by just a few click boxes here to do the same thing, or to even do advanced level control beyond start and stop. Sometimes the OEMs offer various signals you can send, including derate signals, set point signals to the machines. So, you know, any type of other advanced control that is achievable can be looped into your digital solution. In reality, you want something like this because you don't want to have to manage 4 different ways to maybe turn your breakers on, turn your breakers off, turn your turbines on, turn your turbines off. So both from an individual asset level control, also from a site control, which is even more critical. So if you need to do reactive power control, voltage control, again, set point control, you need if you have a large fleet and you're controlling your sites, there is a lot of advantages to just having one system that can, again, touch all 3 or touch all 4 individual SCADA systems and achieve the same results that they could individually, so that you can only need to train, let's say, your operators and your technicians on one system as opposed to 4 different ones. So that's generally, you know, one of the use cases is via control. The other common thing that's really helpful for operators is just reading in and allowing to see all the live alarms as they come in, and the source of the alarms as well, whether it's a condition monitoring alarm, a SCADA alarm, or some type of performance alarm. Being able to drill into these to validate the time periods, to add comments and labels. So from an operations standpoint, those are the most knowledgeable people. So you need digital solutions to allow them to enter free text and qualitative information about outages and events so that can be tracked up to the asset managers. So they don't have to always email or always call the asset manager. The asset manager can just log into the same screen and see, hey, there's been a comment by my site manager on this alarm or this allocation. Now I can clearly see why it's going on and what's being done to troubleshoot that, right? Just being able to run your top statistics, your top 10 hitters on your alarms in terms of lost energy can save a lot of time for operators. So instead of running 4 different SCADA reports for a Vestas and a Siemens and a GE, just having your top 10 stops and alarms by lost energy and being able to drill and to see what machines are affecting the most. So it's a really, hopefully, a value-added time-saving task for operators. Getting into not just alarms, but availability, one really critical thing that we see from successful organizations is that there's at least 1 or 2 people in the operations unit that really pay attention to the accuracy of availability numbers. So what you're looking at here is every line item is basically some type of outage or underperformance that has been logged by your digital system. And you really need a digital system that automates this process. Otherwise, you're going to be pulling and pulling and pulling different manual reports and keeping large Excel files. But if you had all this information automated for all your sites, now at the end of the day, you can just review this 8-hour stop. Perhaps this wasn't a maintenance event. Perhaps this was some other type of event. Maybe it was related to the gearbox. This will allow your operators just to do a quick audit of these outages, which will then allow you to track your availability either contractually or from a GADS perspective to a much higher level of accuracy than what you could without this type of simple manual editing. So event management, I can't stress how important it is, and both engineering and operators really need to pay attention to it and drive the accuracy of the overall events. You should have a system that can produce about 95% accuracy in the way it creates these events, but then that final 5% is always up to the end user. And really, a system was never as smart as the site or regional manager that truly knew what happened on this 8-hour and 34-minute outage. Maybe this was a planned outage. Maybe it was unplanned. Maybe you needed to split this outage into 3 different individual outages that you need to allocate in different ways. So your tools obviously need to support all those workflows in order to get your operational knowledge and your operational data into a usable fashion, to mix that qualitative information with the quantitative information. So at the end of the day, when you're done editing your outages, when operations, and the goal really is for operations maybe to spend a few hours a week or maybe 30 minutes a day, just review that event log and take any stop above 2 hours and just make sure that stop is allocated correctly. You know, the 3-minute and 45-second outage, who cares about that? But if you spend 30 minutes a day, an hour a day, just making sure your top outages are the correct ones, that's what drives your ability to negotiate your availability. That's what drives your performance improvements, because you know you can better allocate what happened on your actual site. It helps executive managers, it helps asset managers understand the data, and it really feeds up as we get into asset managers how they can use the system if that event management and event allocation system is accurate. Cool. We'll go back to the presentation now. Those are just some of the use cases that we see operators use from a digital standpoint, whether it's base field or another system. You know, that's just event and outage management is just a fundamental pillar of what you need from a digital platform. Now, from engineering, engineering has a lot, some of the same kind of overlapping use cases as operations. It always helps, in my opinion, if you had 1 or 2 centralized data analysts that are working hand in hand with operations and reviewing, even auditing that event management process to a final degree. You know, sometimes site managers or regional managers, they're out fixing things. They might forget to look at their outages for a day or 2. Just having that data analyst sitting at corporate somewhere, just looking at, let's say, 3 or 4 sites, and making sure, you know, the things are being tracked accurately is a big help. And really, these engineers, that's what they should be doing. They should be spending 75% of their time or more looking at data. That's what we see from successful kind of engineering groups in organizations. If they're data focused and they're spending most of the time using the systems, challenging the systems, that's where they catch the low-hanging fruit, and also the more detailed and nuanced performance issues, which we'll get into here. You know, site and regional managers, even with just an individual GE SCADA system, they can catch some of the low-hanging stuff. But, you know, from a fleet-wide perspective, you know, an engineer can sit down and look at 5 sites and realize that the same problem's happening on all 5. So that's kind of their role in this. And really not just doing that, but also leading the organization to adopting new tools, adopting new methodologies. If the organization wants to get into AI, really should be engineering trying to lead that, and they should be doing the due diligence and adopting the tools that make sense for the how of how to do things. So beyond event management, we'll get into let's go over some of these nuanced performance issues that maybe operators won't have time to look at, but an engineer that's sitting, for 8 hours a day looking at data, he might be able to find. So we're going to go into, we're going to go back into Bayes Field here, and we're going to go into our little power curve tool, which is just below the availability system. And right now we're looking at, you can see about 3 weeks worth of data for a certain site. And we're looking at about 5 turbines at once. And you can see they're all plotted on the same plot here with all the individual scatter points, lots of data here. These are all individual 10-minute periods. And just having an engineer kind of look at these things quickly, you can see that there's obviously some scatter points that are derated well below the curve. And this is something then with the correct digital tools and their correct training, they can really just go in and do some simple drill downs. So if you want to try to identify what happened here, they can perhaps instead of a single plot, let's go into multiple plots here. So let's break it down. We're going to break it down multiple plots by asset. So now instead of that one plot, we're going to have one individual plot per machine. So you can see now that derate looks like is two of the 5 machines. Looks like turbine 5 here and turbine 1 had some derates happening. So then you want to know when it happens, right? Whenever you look at this type of stuff, before you fix it, before you talk to the GE or Vestas or your operator, you need to give them the most information possible. So let's remove everything besides 1 and 5, and let's just reapply this and just pop those 2 up in our view here, compare them side by side. If we want to do now the win analysis, instead of just looking at aggregate, maybe we want to let's do everything broken down day by day for these 2 assets. So now we're going to get a plot to each machine and each day, so we can clearly identify now what is happening and when it's happening, so we can go to our site manager or Vestas or GE and say, hey, we're having this behavior on these dates at this time. Can you help lead the way in seeing what this is? So you can see, looks like we have some high wind, nothing going on June 14th or June 15th. You can see June 16th, June 17th, both machines, June 18th, June 19th, and June 20th, and a little bit of the 21st. So now you can see, and then it kind of stopped here. So you can at least identify a nice window, and you can really save the operator time. You don't want the operators digging in too much and spending 3 hours on the system. You want your engineers spending a few hours and being able to direct the asset manager and direct the operator into specifically what he should look at and why he should look at that. So that's kind of another example. You might want to automate this process too, right? You might want to set a performance alarm on turbine 1 or 5, or you might want to set a notification. So if I go back to a graph view, and if I'm looking at turbine 1, I might want my system to give me an email or a text alert or an email alert. Let's say if turbine 1 or turbine 5 is underperforming by, let's say, 20% in an hour period. So you can save this, and then your system will then generate the performance alarm for you. So you won't even need to look at your power curve. So just have the system generate these alerts for you. Beyond just performance alerts, maybe your engineer wants to set up lots of different notifications. They want to get an email when a breaker opens. Oops, sorry about that. Something always goes wrong during a demo. They might want to get an email when the machine's been derated for more than an hour. So it's very, you want another system also to be able to pick the site, pick the machines, pick the conditions. So maybe you want to be alerted when a certain air code is a given number. You know, maybe this you've seen in your availability that this air is popping up over and over, and you want to see whenever this air stays active for longer than an hour. So you can set various rules and get either an email or an SMS whenever this rule activates, and you get a clear indication, you know, hey, this machine's been on 277 for more than an hour. You can send this notification directly to the site. You can send it directly to you. It's just another way to quickly get to what you need to without raising false alarms. Really, the biggest part one of the biggest parts in failures of digital systems is is a creation of false data, false alerts. That's when people really lose confidence in the system. And we've seen this over and over, especially in machine learning and AI and all these generated alerts, which can work, but often organizations spend years trying to set up these rules correctly, and the amount of false alarms they get drive operators away from the product and allow them not to trust the product. And that once you have the ground level people not trust your digital tools, it's really hard to overcome that again. So it's important for accuracy, it's important for training. It's important to have people in your corporate office too that are doing a lot of the due diligence and doing a lot of the validation of this before you even kind of roll it out to an operations level team, because their job is super critical, and they can't afford to receive 20 false alarms a day. That will drive them nuts. Cool. So that's a little bit of the engineering use case, and there's a lot more, right? Engineers will want to use algorithms, they'll want to use the API, they'll want to write their own code, they'll want to write their own MATLAB code, develop their own BI dashboards. So you need extendable systems to do that, because engineers are stubborn. I'm a stubborn guy. I want to do my own stuff. I don't want to be told what to do. So in addition to having a standard system, having one that allows you to extend the platform and do different cool things and other tools to make different drill down dashboards like this and another tool, it's really critical. It's really critical in your decision-making process. Cool. Let's talk about asset managers now. Asset managers, like operators, they shouldn't spend their entire day looking at data, because they have a lot of other decisions to make, a lot of other people to talk to, off-takers, engineers, executive managers, et cetera. Really, from a digital standpoint, they should be looking at the financials, right? They should be able to roll up all this data that engineering and operators are allocating, and be able to quickly look at where those losses are relative to their pro forma. So they can quickly stack all these losses that you saw in the event management, and they can compare them to their actual pro forma numbers here and determine what these gaps are. It's always the question, you're 10% down. Is it the wind, or is it because I had curtailment, because I had grid outages? And just a simple view like that, the asset managers could look at and share with the executive management. This is the holy grail of taking your data and doing a one-to-one comparison with your pro forma to clearly indicate both to your team and your executive management team why the site performed the way it did. So again, this can all be achieved in the same platform too. You don't need to go about doing 5 different methodologies and 5 different systems to achieve the whole value chain from operations to asset management. And really, that's kind of just a brief overview of some of the common use cases from a digital standpoint of each group. Executive managers, really, they just need to be driving the culture, right? They should be the ones sitting at top, driving the culture, making sure that these 3 groups below them are working together, using the systems effectively, challenging their numbers. And if you have that culture top down, I think you're going to be successful. So that's my presentation today. Keep it simple, stupid. Don't overthink the problem. Pick the right tools, stick to them, get trained, don't get frustrated, keep moving forward. Thanks a lot, and I'll take any questions now.